did last week was I introduced us to the idea of lists, right? Lists are some kind of data type, right? That is essentially used to, um, store data, literally. So think of your Excel sheet, right? You have those cells. Somehow you want to figure out a way to store information in all of those places. And I talked about the idea of lists in Python. So if you let me just look for a graphical representation of what a list is. A couple of things that I mentioned about list, right? Um, so this is an example of a list, what you have here, right? So a list, it can store any number of data types, actually. It's not just strings. And then for each of those things, think of it like a house, right? I talked about, I think the specific description I talked about is like a block of flats within a neighborhood. Each and every one of them, somebody is occupying them. But guess what? Each of them has an address. So what I mentioned, 0, 1, 2, 3, that's how you address it. Usually because of the unique way computers are set up, they read binary. And then when you look at decimals also, we do decimals from 0 to 9, and then we reset, start 10 to 19, and we reset. So when we do this counting in trying to find the specific address of each element, right, within a list, we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You go that way, and that's how we find the address. So we did all of that. This is a more descriptive picture, for example, of a list too. Let me see if I can um like if I can find that. Oh yeah, go back one bit. So it doesn't exactly track, but you see what's going on here, right? So this is a list, and usually a list is enclosed in a square bracket, right? And then you have the occupants of that list are like G, E, E, K, S, F, blah, blah, blah to S. And if I'm trying to address it to identify where everything is right within that list, I can count from 0, 1, 2, 3, 4 to infinity. But another way to do the counting is to begin to count from the last cell and go back the other way. And instead of starting from 0, usually you start from -1 and then you go back. So essentially, this is what a list kind of looks like. So I'm going to go back there, and some of these we already talked about last week. That's why I'm not going to dwell on it, a lot today. So, and I've posted a video there where you can actually see, and we talked about how to access a list, right? And for example, a list of bicycles. So I'm looking at a list of bicycles, and then we gave specific list of bicycles, and then we said if we want to access this particular the first element or type of bicycle here, we use 0, right? If I want to access the one in index 3, what's index 3? 0, 1, 2, 3, which is in the 4th place. So all of that, and then it talks about how index positions work, and then individual values from a list, and then we actually went along to talk about the F string, right? And um, how it's used in the context of trying to access elements within a list. And then we talked about methods. So when you have something like dot title and all of that, what those methods are. And I did mention that a lot of these, like the method is a special type of function. I talked about abstraction in programming, and an example, specific example I used about abstraction is like you're sitting in a car and you have your accelerator. Now, even though that's just a simple pedal, that's not what really drives the car. What it is, it's assuming your engine and all of the other things within your bonnet, right? Everything that drives the car, but the what you might call it now, the pedal, you know, makes a function call. Supposing all of the things in your bonnet like are what we refer to as functions, right? Then what makes the call to that function is your pedal, your accelerator, right? Once you press it down, all of a sudden it gets power from the other side. That's exactly what's happening with a lot of these methods and functions, right? They are written internally in Python, and each time you want to call them, you just, use the specific verbiage or variables or whatever to call them. And as any other language, right, the only way you can know what to call is because you're versed in the language. So in your native language, there are certain words someone that is not really versed in your language would know. So that's why you need to interact with the software, the programming language, and that's why it's a language. You need to understand the language and know what it is, specific words that you can use to call up whatever it is that you want to call up, right? So, and um, I've done all of this, which again is the reason why I want every one of you to go through the book and create your own notebooks step by step, because that way it reinforces the concepts I'm trying to teach. So we did go through different kinds of methods. For example, append, how to append elements to the end of a list, how to modify elements in a list. We went through all of that. Inserting elements into a list, how to remove elements from a list, and then how to pop elements from a position within a list. We did all of that. And then sometimes we just want to remove an item by value, right? How do we do it? We did all of that last week in chapter 3. So I encourage you to go do it. So when I set up, the area for the submission of your assignments, one of the things you would need to do is to submit your notebook for chapter 3 and chapter 4 after you've gone through it. Okay, so that now takes us to chapter 4, but we are still working on lists, you know. So it says lists looping is one of the most common ways a computer automates repetitive task. So this is essentially beginning to introduce us to what we refer to as the for loop. And now that you know about list, you can actually now use the for loop to iterate. In other words, go through elements in it and apply specific actions on them. So it says looping is one of the most common ways a computer automates repetitive tasks. You can loop an instruction when you want to run through all entries in a list performing the same task with each item. The code below can be read as for every magician in the list of magicians, print the magician's name. So let's actually just focus on this. Let's focus on this code. I'm sure you all can see this code. Now look at this code, right? The code, the variable here is magicians, right? And then I created a list, or a list was created. Now, if you look at that list, what makes it a list, right? It's essentially you have a square quotation mark into which you put the strings, right? And remember, I mentioned to us a string is just a group of characters that are together, and then you have quotation, open and close quotation marks over them, right? That's what a string is. So here you have 4 strings: Alice, David, um, Caroline, and Noble, right? That's this string. And this is a specific data type. Remember, we talked about different data types, right? Beyond string, you have other data types, like Boolean, you have like your numbers and all of that, right? Floats, all of those kind of and one of the interesting things about that's a list is that it doesn't have to be a string, right? It can be a float, something like 3.14 can also be part of it. So if I run this through, see 3.14 also shows, right? So it doesn't just have to be a string. There are certain data types where it just has to be one data type or the other, but that's it. So notice what's happening here. Now that's where, after getting our string, that's where we now begin to talk about our for loop, right? What is a for loop? A for loop just helps you loop an instruction through the elements in a list. So for example, I already know what my magician is. So all I just need to come here is said I will say for magician in magician. So the nature of the syntax for, let me go to the internet and just show you syntax for loop. So this is what the syntax for loop is. Let's um, Python for loop, right? So a for loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string. And we are going to, look at these different different data types, tuple, dictionary, set, and they all do different things. This is less like the for keyword, in other programming languages, and more like an iterator. So in other programming languages, the for loop is used a little differently, but here it's mostly like an iterator. It helps iterate things. So this is a typical example of what the syntax would look like, right? Fruits is equals to apple, banana, cherry, right? And you only need to say for this in this. And the X and the fruits, you can choose whatever it is that you want to choose, anything, but you want to be able to choose something that makes sense, right? So for example, if I choose something like people here, right, and I put the name of a couple of persons, I can say for people, in something that relates to those people, right, is what I will use here, so that it's readable even to yourself. So that's kind of what the syntax for the for loop looks like. So if you come in here, right, you have magicians, but I want to make a distinction because this is the list of magicians, but I choose sorry, uh, this is a list of magicians, but each of them, for example, is a magician. 111. That's why I said for magician in magicians. So I'm trying to loop through the magicians within this list called magicians, right? So that's what we have, and then you print it, and then you get this. That's a typical example. Now, look at this. Line 2 above tells Python to pull a name from the list of magicians and associate it with a variable that is referred to as magician. That's exactly what's happening here. So, and the second thing that is listed here is where I tell you that you can literally choose any name. You're not stuck with any particular name. The only thing that is really important is the things that are in green, which is for and in. Notice those are reserved names, right, for within Python, and that's why they are colored differently that way. So the next thing, so for example, these are some ways, for example, that you can decide to, you know, for nomenclature, for example, for cats in cats, for dogs in dogs, for item within that's in list of items, just that's the general naming convention. So it says the naming convention above can help you follow the action being done on each of the item within that loop. So using singular or plural names can also help you identify whether a section of a code is working with a single element from the list or the entire list, which is what we did here, right? By just using one as singular and the other one as plural, we are able to know which variable you're talking about. So in this case, right, the variable you're talking about here is the list, but here are the individual elements within that list. Questions? Does anyone have any questions? No, yes, maybe. Okay, so I'm going to proceed, right? So look at the additional thing. So we're gradually, the author of this book is gradually actually developing that idea and the content, right? So we still have our list. Magicians is equals to Alice, David, Caroline. Now for magician and magicians, we're saying print. Then I want to write a sentence, and one of those ways I can do these constructions where I can actually pull information from a variable is to use the f string, right? And I did talk about the f string in the video of the second week, you know. So essentially, we start by writing out the magician, right? Dot title, and dot title is a method, and then so first of all, to write this, so notice what's happened here, right? To write an f string, you start with your f, open and close parentheses, and then within it you can now point to whatever it is, whatever variable you're trying to use, and then you can go from there, and then comma, and then whatever sentence you want to. These sentences have nothing. So these are just ordinary sentences, a bunch of strings. But then what is different here is the variable. And then with that, notice that it's one S, which means you're trying to loop through the content within um, within the list. So if I run this, this is what I get. Right. In other words, what it's done, like I mentioned, what the for loop does is that it iterates over all of the content. Let's assume that I add more names, right? And I say Kingsley, right? And I say Angela and all of that. So if I run it again, it's going to include Kingsley. Oh, my Kingsley isn't a king enough. G, then I run it again, I'm going to get all of them. All it just does, the for loop, is to help me instead of writing a line of code for each of them, right? It will can use one line of code and then iterate over all of. So if there are a million elements in this thing, right? Let me just double the number of people here, and you see how it just within a second it loops through everything again quickly. So you don't even have to think, it just does that. So that's the magic of the for loop. And essentially what we have here, right, is the for loop interacting with a list. Okay, so it says you can also write as many lines of code as you like in the for loop, right? Every indented line following the line for magician and magicians is considered inside the loop. So in Python, the idea of indentation is very important, because once you indent something, so what I mean by the indentation is typically 4 spaces. And when you're coding, instead of using 4 spaces to be sure, all you need to do is to use what do you call it? Your space, your tab function, usually at the right corner of your keyboard. Once you tap, so let me show you what I mean. So if I go this way, let's assume I add a line of code here and a line of code. So I'm going to tap with my space bar, 1, 2, 3, 4, right? But instead of doing that, it's safer to just go tab, hit your tab function, which is usually by the left side of your laptop. So I'm just going to tab once and it will give me those 4 spaces. I just did that now, right? So once you have a line of code under another line of code. See, the for and the print are on different lines. So what this essentially says is that print these two lines of code under for would have to submit to whatever for is doing. That's essentially what it is. That's what it is here. But if I move this and I put it here, then it doesn't follow whatever is there. So see what happens. Let me try to um so let's run it again so you can see what I mean. So notice how many lines of code I printed. This is one print, this is two prints, right? Two lines of code. It's saying magician.title. That was a great trick. And then the second line says, I can't wait to take your next, to see your next trick, right? And then it lists the name of the person, right? That I want it to go in there. But notice another thing, this /n is saying add a new line, which is why you have this space here, right? Add a new line before you do the next iteration, which is for David. So the first one is for Alice, for David, and then for Caroline, right? So that's what's happening here. And then how do you call Alice, call each of the elements? You use the magician.title. Same thing you do here at the end, magician.title, and that's why you see Alice, David, David. So imagine if I wanted to add another line, right, that doesn't loop directly on that. Notice now, count what we have here. These are 6 lines of code, two each of them. So let me run that now. See, this guy is standing on his own. I can't wait to see because it doesn't loop through all of this, right? It just goes through the last number I could pick. So there's implication in how you use your indentation. That's the point I was trying to make there. Questions? Any questions? Okay, so and this is the line thing I was telling you, and the way I've created the notebook is kind of what I expect from you. So the new line /n in the second print, which is this, right? This point here. In the second print method, sorry, the new line in the second print, which is this second print that we're talking about here, inserts a blank line after each pass through the loop, which is the whole thing I mentioned. So this creates a blank line because this is literally how in Python you are able to say, hey, create a new line /n is for a new line. So what if I want to look at this code again, doing something after a for loop, right? I'm trying to, and that's on page 52. We have magicians is equals to this. For magicians in magician, then I print my first page and it's saying something like magician.title. So let me just use the first one for example. This is saying Alice, that was a good trick. I can't wait to see your next trick, Alice. Thank you everyone. That was a great magic show. All right. So that's a one of those. So if you did this, this is what you get. Alice, you can see there's a space here before the thank you. Why is there a space? Because you have this N here. Ideally, you don't want this to be this way. Ideally, I will want to do more or less something like this, and that will correct the error that you have there. So now it's going to print as it's supposed to print. And that's the magic of the new line. Okay. So what's an application of what we just did? I know we have just coded around that now. What's an actual application of that? So when you're processing data using a for loop, you will find that this is a good way to summarize an operation that was performed on an entire data set. Like I mentioned to you, if I had 1,000 elements, right, and I want to run through them, maybe I'm looking for a particular thing, right? I'm trying to flag an error or something. I can't go through all of that. Using your for loop is fantastic for iterating through all of the elements within a space, the space within a list, right? So for example, you might use a for loop to initialize a game by running through a list of characters and displaying each character on the screen. You might then write some additional code after this loop that displays a play now button after all the characters have been drawn to the screen. That's giving you an example of a game, right? You're trying to write a game, you know, and then you wrote a game and someone turns on the game, and the first thing is it will list all of the, say it's a soccer game, right? It will list all of the players on both sides, right? How do you want to do that, right? If I want to write a game that has players from both sides, right, I will have to put them team A equals to, then I'll create a list and put all the names of the people. Team B is equals to this, then I'll use a for loop to display all of their names, right? That's an example, a very good example. And the next one talks about those indentation errors. I think I already discussed with you the indentation errors. And when you read through the text, you're going to actually also see a whole bunch of things about some of those and additional things that have been discussed about in indentation, because the way you indent really does matter. And this is another example. I think I already gave an example that is similar to this, you know, um, same thing. So you be careful how you indent. So essentially, we are done, as it were, for with with that part of it. So if I want to make a numerical list, right now, think of it, lists, list, are ideal for storing sets of numbers, right? And Python provides a variety of tools to help you work efficiently with a list of numbers. Once you understand how to use these tools effectively, your code will work well even when your list contains millions of items. So let's look at this. We can use range, the range function. Like I mentioned to you, right? These functions are pre-written functions, right? So when you know the name of the function, all you need to do is call the function without writing reinventing the wheel. You already have the function. All you need to do is boom, and you get the function. Let me show you range range in Python. So this is the range function in Python, right? And what is the syntax? Because I do this because I want you, each time you're thinking of a method or a function, right? You can always just go do some research on it immediately and you understand. So for range, what are some of the things I need if I'm trying to use the range function? So this is what the syntax looks like. You have a start, some number you're starting with, you have the final number you're working with, and then you have the steps that you want to take to get there. So let's say my first number is 1, and then my last number is 10. And what's my step? I want to do 0.5. So if I run something like this, it is going to break everything down in the order in which I have stated it, which is why if you go back here, so look at this. Let me go. Okay, this is a particular example. Let me see. Oh, it's not logged in. So if I run this, for example, look at what it gives me: 3, 4, 5. So I'm looking for a range from 3 to 6, right? But notice it didn't give me the last. Look at the syntax. I say something about it's supposed to be start, stop, and step, right? But see what's written here, because this is important when you're thinking about the parameters. These things inside the parentheses are referred to as parameters. So for start, right? Start is optional. But what is really required is the stop. The step is also optional. So in this particular case, what they did is they used the start, the stop, but didn't use the step, right? So it says when you don't use the step, guess what happens, right? The default will be 0, which is why when you run this, right? Sorry, the default will be 1. So when you run this for this range 3 to 4, it just goes one step, 3, 4, and 5, right? And that's the range that it takes, right? So let's come back here. So for this we're also looking at using the range function. Here, notice it gave us the first, the start and the stop. There's no step, right? And then if we run this for this value in within this range, we will get 1, 2, 3, 4, because it just did 1, 1. So let's assume that I add cosine it. So I use 2 as my range. So this is so you see it's jumping, skipping every 2 steps, and I keep the numbers 2 steps. So in other words, 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, same thing. So let's say I change this to 5, right? It will now do skip 5, 5, 5. So 6 minus 1, 5, 11 minus. So essentially that's how this works. But if I remove it, right, it assumes that my step is 1. So I run this, boom, and it does 1, 1, 1, 1, 1. So if I want to run through a range of numbers, right, I can actually use my for loop and my range to iterate over that particular range. So that was the point of the conversation. So range is one of those. So it says Python's range function makes it easy to generate a series of numbers. So if you want to generate, and there are all kinds of reasons why um, you do that. So this is another result of the off by one behavior you see often in programming languages. The output never contains the end value. Notice that. I'm sure some of you will be wondering, right? Which could have been 5 in this case. So it didn't give us the last value. To print the number from 1 to 5, you would use the range 1 to 6. So that's one of those really peculiar things about this. So again, it's a language you need to understand, the rules around the language. So assume we want to now create a list of numbers, right? Because remember, we're talking about list, right? And gradually we're trying to figure out a couple of things, behaviors around using a list. So in this place, it says you can actually use a range to make a list of numbers. So if you want to make a list of numbers, you can convert the results of range directly into a list using the list function. So it's better understood when you look at an example. So say I want to create a variable called numbers, and what I want is a list. So I say to create that list, right? I just say list, then open and close parentheses, and then within it, I now say range 1 to 5, right? Once I click print, it will create the list for me automatically. So it has done that, and this is what you have here. So let's say I want to create a list with this number of within the range 1 and 50. I run it. See, I've created this list. So range actually helps you create a list of numbers, you know. So that's one example right there. If I want to create a list that includes 500 numbers, guess what? Boom, I've created it. So if I want to create a list that has 500 numbers, but they go through steps, two steps, right? I can do that too. 3 minus 1, 5 minus this. So I've created a whole list. Open bracket, close bracket. Make sense? So I'm going to get all of this out and then create my small list. So I already talked about this where you can actually tell Python to skip numbers by including your steps. That's why it's always good for you to go look at the syntax of whatever words you are things you're using. So the other one is you, notice you can create almost any set of numbers you want by using the range function. You can do that. For example, consider how you would make a list of the first 10 square numbers. That is the square of each integer from 1 through 10, right? In Python, double asterisk represents exponents. So if I'm trying to say something is to the power of something, generally in a lot of maths representations, you use double asterisk. So let's say I'm trying to create a list where I create a list that continues the squares of all of the numbers that I refer to. I'll just say squares, right? And then first of all, I create my list. So this is what you will refer to as an empty list, you know. And the other thing I want you to do when you do your notebook is it will be good that you write the comments, right? So you write comments on the side, empty list. So you say something like empty list because it will be good for your own understanding when you're reading these things. You can always say okay, and then I will say a for loop. I'll say something like a for loop with a range function, things like that. Because something like this would, first of all, demonstrate that you understand what's going on in that code. And not only do you understand, especially if you write a code and you're leaving out that code and some other person is supposed to go through that code and doesn't know what you were doing, just by reading your comments, they will be able to understand what's going on in that code. And I think that's going to be a major part of the last assignment we're going to do in the course, right? I mentioned I don't have a problem with you. I've already, it's available in the syllabus I've created, what the last assignment will look like. Yours is to just go ahead and write a code based on the instructions that were given to you. But I also realize that in today's world, a lot of people might go use ChatGPT. It's okay to use ChatGPT for that assignment, but at the end of the day, that particular assignment, but at the end of the day, you need to be able to debug it because a lot of times ChatGPT is not going to give you the right answers or, so you need to be able to debug it. You have to be able to refactor it to make it good code, and you need to be able to using comments, right, and an explanation that you're going to provide later to actually tell me what's going on and what's everything in that assignment. So one of the strong skills I want you to walk away from this class is the ability to understand code, read code, edit code, because that will be the bulk of what you're going to be doing in the next course, which is your data science course. So now notice what's happening here, right? So here, my next comment will be something like, I will say something like, and notice what I'm using. I'm using the pound sign, right, to comment out those words. In other words, Python can't read them because I use that pound word, right? So I say square values, so this is like create square values, you know, um, values. That's what's going on here. And then the last one, if I include my comment, what I'm trying to do here is, this is very good practice to include your comments, right? Append the squares into the empty list. So that's what I'm trying to do there. Okay. So, and then finally, this is just printing out, printing out, printing out the list. So that's what's going on there. So imagine this, if I gave you this and you're reading this, it's easy for you to actually see what's going on there. So I'm going to create an empty list first. I can do that by just creating a null list. Now, remember my for, what my for does is it iterates over a bunch of things, and it's here. I'm creating, and look at the reserved keywords, it's just for, in, and range. You can see them in green colors, right? The only thing that you created, which you can use anything for, is what's in here, right? So I'm trying to loop around everything within the range 1 to 11, right? So, and then when I do that loop, notice that my square is indented within the 4. In other words, this, whatever instruction is here, will be applied to everything that is indented under it. And guess the other thing that is very important, this column. This column is important because that's the nature of your for loop in the syntax. So I will now say I've created a list of these numbers, and then I'm creating a second variable, which is my square, and that my square will be whatever I get from here to the power 2, right? And then everything that comes from there, I can now append them into squares. That's why you have squares dot append. What am I going to append? Everything that comes from square. That's literally what's going on here. So if I run that, that's how I have this. Assume that I decide to make this, instead of 11, I make it 110, and that's what I'm doing, right? I'm squaring all of that. So what if I decide to be like, okay, let me do them in steps of 4? Boom, this is what I get. Make sense? Questions? Any questions? I want to make sure I still have people here. All right. So,
No questions.
right. So, um, there's also something referred to as refactoring, right? Which, where you try to, sometimes you have text that is so verbose, and what you want to do is to refactor it, right? In other words, trim it down, you know. So to write this code more concisely, you can actually omit the temporary variable square. So look at the way you do it, right? Notice, yeah, because if you come here, the square is the same thing as the square here. So that's kind of redundant. So instead of going to write square here, just copy this and put it in place of the square. That way you're saving a lot of real estate, and that's how you refactor code, right? And then you run it, and then you get the same result. But the truth is that you can use any of the approaches. The only thing is sometimes some code look better written, and sometimes it's depending on the readability. That's your only other thing. You want to also make it readable for some audience, depending on who you're writing for. So the secret is, write the code in whatever way that is easy for you, and then the next step is you now look for, are there ways I can get the same result by compressing things together, right? More efficient approaches to make that thing shorter, and you know because it also helps the computer in sometimes, right? Because it shortens the number of operations that is even necessary in some kinds. And then when you go into real programming, that's when sometimes how quick your code runs now become very important, because you don't want it consuming more computational power that is necessary. But at this stage, I think the important thing is just to understand how to code and what you're doing to get to the point, step by step, logical, or what I would refer to as computational thinking. You want to be able to establish that first, develop your memory muscles so that it comes automatic to you. You know what you're doing, and then later you can go into efficiency, code efficiency. So, how are we doing with time? Do we want a little break, or do we just keep going? I want some feedback from you. Do we continue? Um, because I'll probably just continue if,
Yes, sir.
yeah,
Later
okay.
we can continue. Yeah.
All right. Yeah. So look at the next one, right? The other thing is, uh, so look at the first thing that we have here, simple statistics with a list of numbers. If I have this bunch of numbers, this definitely you can see is a list, right? Now, this list, I can do all kinds of things with it. I can say, okay, let me find the minimum number in this list, right? The minimum number here is 0. So how do I find that? I just say min, which is its own function in there, and max. I can find the maximum number here by just typing